Hi there, Joshua here. Now I don't allow any mobile phones in my classroom. In my classroom, mobile phones are not allowed. We were doing algebra, and I said to this kid, I said, 8G take away 5G, I said, 8G take away 5G, what have you got? He said, I've got 3G. I said, you've got 3G? You've got 3G? I thought I said no mobile phones. Get out. And stop showing off, I've got 4G. So there. Let's start the lesson. Right, so completing the square. Completing the square is about quadratic expressions, expressions with an x squared term basically. So for example, x squared plus 8x plus 1 is a quadratic expression because it's got an x squared term. And completing the square is just about rewriting these sorts of expressions in a different form. So it's taking an expression like this, an expression of the form x squared plus something x plus something. B and C are just the numbers in the expression. In this case, B is 8 and C is 1. But it's taking an expression of this form and just rewriting it as x plus something squared, like that. And then maybe a number at the end. So it's taking an expression like this, x squared plus something x plus something, and it's rewriting it in this form, x plus something squared, with maybe a number at the end. And that is called completing the square when you do that. Completing the square. So now one of the reasons you might do this is because it's useful for solving quadratic equations. So what I'm going to do this lesson is I'm going to show you how to complete the square, just how to rewrite an expression like this in this different form. And then next lesson we're going to apply this method to some quadratic equations. Right, let's do some completing the square. So in the first few examples, I'm not going to have a number at the end of the expression. It's just going to be the expressions are just going to be of the form x squared plus something x in my first few examples. So the first one's going to be x squared plus 10x. And let's complete the square. That just means rewrite it in this form as x plus something squared. So we want to rewrite it as x plus something squared. So to work out what number goes here, you just halve the number in front of x. Half of 10 is 5. So it's going to be x plus 5 squared. Now, is this the same as the expression we started with? Or let's just check at the side. If you do x plus 5 squared, in other words, x plus 5 times itself, x plus 5 times x plus 5, let's see what we get if we expand that. So x times x is x squared. X times 5 is 5x, and another 5 times x is another 5x, so that becomes 10x. And then, so we get that stuff, but we also get 5 times 5, which is 25, which we don't have up here. So when you expand this, you get x squared, you get 10x, but you also get plus 25, which we don't have up here. So to make this the same as that, you just need to take away the 25. Now they're the same. So you just need to take away 5 times 5, 25. And that's it, that's completing the square. So we've taken an expression of this form, x squared plus something x, and we've rewritten it in the form x plus something squared. And notice there's a number at the end as well. Right, let's just do a few more. So x squared plus 6x. Let's complete the square. In other words, rewrite it as x plus something squared. So what number is going to go here? Well, as I said before, it's half the number in front of x. So half the number in front of x, so it's half the coefficient of x. So half of 6 is 3. So it's x plus 3 squared. And if you were to expand this, in other words, if you were to do x plus 3 times another x plus 3, you'd get x times x, you'd get x squared. You'd get 3x and another 3x, which would be 6x. So you get that stuff, but you also get 3 times 3, because there'd be a 3 in each bracket, and 3 times 3 is 9, which you don't have up there. So again, you've got to take away 9. So you always take away this number squared, basically. So that's it, we've completed the square. We've written this in the form x plus something squared. Let's just do a couple more. So x squared plus 14x. Let's complete the square. So it goes to, in other words, writing it as x plus something squared. So, yeah, what number is going to go in the bracket? Well, half of 14 is 7. So it's going to be x plus 7 squared. And if you were to expand this, you'd get x squared, you'd get 7x and 7x, which is 14x, but you'd also get 49, because 7 times 7 is 49. So that's the thing you need to take away to make this the same as what we started with. So that's what that goes to. So we've done it. Let's just do a couple more. Let's do a couple with negative numbers in front of x. So let's do x squared minus 8x. Let's complete the square. So same idea, it's going to be x plus or minus something squared. Half of minus 8 is minus 4. So that's the number that goes in the brackets. So it's x minus 4 squared. Now do we still need to take away something? Well, let's expand this. Let's do x minus 4 squared at the side. In other words, x minus 4 times another x minus 4. And let's see what we get. So x times x is x squared. X times minus 4 is minus 4x. And minus 4 times x is another minus 4x. So that makes minus 8x overall. Minus 4x is minus 8x. So we get this stuff. But we also get minus 4 times minus 4. A negative times a negative is positive, so it's plus 16. Minus 4 times minus 4 is positive 16. So when you expand this, you get all that stuff, but you still get a positive number. You get plus 16, which needs to be taken away still. So you still take away a number. So you always take away this number squared. Minus 4 squared, minus 4 times minus 4 is 16, so that's what you need to take away. Right, let's just do one more down here. So x squared minus 12x. Let's complete the square. So in other words, write it as x plus or minus something squared. So half of minus 12 is minus 6, so that's the number that goes in the bracket, 6. And if you were to expand this, if you were to do x minus 6 times x minus 6, you'd get x squared, you'd get minus 12x, but you'd also get minus 6 times minus 6, which is positive 36, so that's the number that needs to be taken away. And we've done it. Right, let's do a few quadratic expressions with a number at the end. So let's do x squared plus 4x plus 7. Let's complete the square. So for these, what I do is I kind of ignore the number. I just focus on the first two terms. So the x squared plus 4x, this bit. And I complete the square for those terms. So what does x squared plus 4x go to when you complete the square? Well, it just goes to x plus 2 squared, because half of 4 is 2. But then you've got to take away 2 squared, 2 times 2, so you take away 4. So this is now the same as what I've underlined. We've completed the square, but then you just stick the plus 7 on the end, so plus 7. And then you can just simplify that. So it's x plus 2 squared, and then minus 4 plus 7 simplifies to plus 3 overall. And that's it. So we've written this expression as x plus something squared, and then with a number at the end as well. Let's do a few more of those. Let's do x squared plus 6x minus 5. Let's complete the square. So again, I kind of ignore the number. I'm just going to focus on the first two terms and complete the square for those two terms. So what does x squared plus 6x go to when you complete the square? Well, it goes to x plus something squared, and the number is going to be half of 6. It's going to be 3. So it's x plus 3 squared. Then if you were to expand this, you'd get 3 times 3, which is 9, which we don't have up there, so you've got to take away 9. Now this is the same as what I've underlined, but there's also a minus 5 in the expression, so I'm just going to put a minus 5 on the end, and we can just simplify that. So it's x plus 3 squared, x plus 3 squared, minus 9 minus 5 is minus 14 overall, so minus 14. So you kind of ignore the number, or this is how I do it, I ignore the number and then I just bring it in at the end. Let's do a couple more. Let's do x squared minus 10x plus 1. Let's complete the square. So again I'm going to ignore the number. I'm just going to focus on x squared minus 10x. So what does that go to when you complete the square? Well, it just goes to x plus something, plus or minus something squared. Half of minus 10 is minus 5. So it goes to x minus 5 squared, but then minus 5 times minus 5 is 25, which isn't up there, so you need to take away 25. So now this is the same as what's underlined, and then just stick the plus 1 at the end. And we can simplify that. It's just x minus 5 squared, and minus 25 plus 1 is minus 24 overall. Minus 24. And that's it. Let's just do one more. Let's do x squared minus 14x minus 6. Let's complete the square. Okay, again I'll focus just on the x squared minus 14x. I'll sort of ignore the 6 for now. Just bring it at the end. So what does x squared minus 14x go to when you complete the square? Well, it goes to x, again, plus or minus something squared. And what's the number here going to be? Well, half of minus 14 is minus 7. So it's minus 7. And if you were to expand this, you'd get all that stuff, but you'd get a plus 49, because minus 7 times minus 7 is 49, so which we don't have up there, so we need to get rid of that. Now this is the same as what's underlined, and I'll just stick the minus 6 on the end. Let's simplify that. So it's just x minus 7 all squared, and minus 49 minus 6 is minus 55. So that's it. Right now, in all my examples, I've deliberately avoided having a negative number, having an odd number in front of x. If you've noticed, I've used even numbers every time, and that's because you halve these numbers, and that's what goes in the bracket. But let's do a couple, just to finish off, let's do a couple with odd numbers in front of x, let's see what happens. So I'll do, let's say x squared plus 5x minus 3. Let's complete the square. Let's see what happens. So you do exactly the same thing. So again, I'm going to ignore the minus 3 for now, just focus on x squared plus 5x. So what does that go to when you complete the square? Well, it goes to x plus something squared. Half of 5 is 2.5, but it's easier actually to leave it as a fraction, as an improper fraction, a top-heavy fraction. So 5 divided by 2, you can just write it as 5 over 2. 5 halves, so 5 over 2 like that. One reason for doing that is it's easier to square, it's easier to multiply it by itself when it's in that form. Because remember, the number you take away is this number squared. And 5 over 2 times 5 over 2, you can just do 5 times 5 and 2 times 2. You just square the top and square the bottom. So 5 over 2 times 5 over 2 is 25 over 4. And that's what you need to take away, 25 over 4. And now this is the same as what's underlined. And now I'm going to bring the minus 3 into it. Now to simplify this, I have to sort of bring these two numbers together. If I write them both as fractions, so if I write 3 as 3 over 1, and try to get the denominators the same, then I can combine them. So I can get this to a fraction out of 4 by multiplying top and bottom by 4. So I'll just do that on this line. So that'll be x plus 5 over 2 squared. I'm just copying everything out, minus 25 over 4. And I'll just multiply top and bottom by 4. So 1 times 4 is 4. 3 times 4 is 12. So 3, or 3 over 1, is the same as 12 over 4. So now I've got that, and now I can simplify it. So it's x plus 5 over 2 squared, and minus 25 over 4 minus 12 over 4. Or minus 25 minus 12 is minus 37. So it's just minus 37 over 4. Now that was a bit tricky, so I'm just going to do one more example like that to finish off. X squared minus 3x plus 7. Let's complete the square. This is the last example. So again, I'm going to ignore the 7 for now, just focus on the first 2 terms. So what does x squared minus 3x go to when you complete the square? Well, it goes to x plus or minus something squared. And the number here is half of minus 3, which is minus 1.5. But again, it's easier to work with if you write it as a fraction. So minus 3 divided by 2, you can just write as minus 3 over 2. It's an improper fraction, a top-heavy fraction. Again, it's easier to square, because if you were to expand the bracket, you'd get that stuff, but you'd also get minus 3 over 2 times minus 3 over 2, which is the same as 3 over 2 times 3 over 2, because a negative times a negative is positive anyway. So to work out 3 over 2 times 3 over 2, 3 times 3 is 9, 2 times 2 is 4, so you get 9 over 4, which you don't have up here, so you need to take that away. Remember, you always take away this number at the end squared. Then I'm going to stick the plus 7 on at the end. And if we write 7 as a fraction, if we write it as 7 over 1, remember you can always write you can always write a whole number as a fraction over 1. Then we can sort of combine these two together. We need to get 7 as a fraction over 4. 7 over 1, we need to change that to a fraction over 4, then we'll be able to add them together. So we'll do that on the next slide. So you get x minus 3 over 2 squared minus 9 over 4. And by multiplying top and bottom by 4, we can change this to a fraction out of 4. 1 times 4 is just 4. And 7 times 4 is 28. So we can write 7 over 1 as 28 over 4. Now we can add these together. So let's do that on this line. X minus 3 over 2 squared and minus 9 over 4 plus 28 over 4. Well, minus 9 plus 28 is the same as 28 minus 9, which is 19. So you get 19 over 4. So that's how it simplifies. And we've done it, we've completed the square. Right, I've had enough of completing the square. If I have to complete the square one more time, that's it. Yes, we've done a lot of completing the square today. Next lesson I'm going to show you how we can apply this to solving quadratic equations. So that's going to be in the next lesson. But for now, I'm going to put some questions at the end of this video for anyone who wants to practice what we've done today. As I always say, the best way to improve in maths is to watch my videos, obviously, and practice questions. So I'll put some questions at the end, and you can have a go at completing the square. I'm also going to put the answers after that, so you can pause the video, have a go at the questions, and then look at the answers. And make sure you do the questions first this time. Right, here are the questions. Bye.